Howdy, folks. Let's talk about something really, really big. In fact, let's talk about the biggest thing there is, the universe. When we say universe, we're not just talking about the stars you see twinkling in the night sky. We are talking about absolutely everything. That includes you, me, this screen you're reading, and the very air you're breathing. It's all the space, all the time, all the matter, and all the energy that has ever existed or ever will exist. It's a concept so vast it can make your head spin. But don't you worry, we're going to break it down together. It's a grand cosmic adventure, and you've got a front row seat. Consider this. Our planet Earth is like a single grain of sand on an unimaginably large beach. It's part of a solar system orbiting our star, the Sun. But our Sun is just one star among hundreds of billions in our home galaxy, the Milky Way. And guess what? Most of those stars have their own planets, which we call exoplanets. That means there are potentially trillions of other worlds out there just within our own galaxy. It's a mind-boggling number, isn't it? Every speck of dust, every distant star, every single thing is a piece of this grand puzzle we call the universe. Now hold on, because it gets even bigger. Our Milky Way galaxy is not alone. It's just one island of stars in a cosmic ocean that contains billions, maybe even trillions of other galaxies. Each one of those galaxies is a sprawling city of stars, dust, and planets, all bound together by gravity. Some are spiral-shaped like ours, while others are big, fuzzy ovals or even irregular blobs. They are all drifting through the immense emptiness of space, part of a cosmic web that stretches farther than we can currently see. It's like a giant cosmic neighborhood, and we're just getting to know our neighbors. So when you look up at the night sky, remember what you're really seeing. You're not just looking at little points of light, you're peering back in time and across incredible distances. You're looking at the building blocks of everything. The universe isn't some far-off place that's separate from us. We are in it, and it is in us. The very atoms that make up your body were forged in the hearts of stars that exploded billions of years ago. We are, quite literally, made of stardust that connects every one of us to the grand, sweeping story of the cosmos. Now, where did all this, come from? That's one of the biggest questions in all of science. The leading idea, our best explanation so far, is called the Big Bang Theory. About 13.8 billion years ago, everything in the entire universe, all the matter and energy, was crammed into a single point that was unimaginably hot and dense. It was smaller than the period at the end of this sentence. Then, in a fraction of a second, it didn't so much explode as it did expand. It was a moment of incredible rapid inflation that kicked off space and time and the universe as we know it. To get a handle on this cosmic expansion, think about baking a loaf of raisin bread. Imagine the dough is space, and the raisins are galaxies. As you bake the bread, the dough rises and expands in every direction. From the perspective of any single raisin, all the other raisins seem to be moving away from it. And the farther away a raisin is, the faster it appears to be moving away. That's a lot like what we see with galaxies in our universe. They aren't flying through space, but rather, space itself is expanding and carrying the galaxies along for the ride. Another great way to picture this is to grab a balloon and a marker. Before you blow it up, draw a few dots all over the surface. Each dot represents a galaxy. Now, start blowing up the balloon. Watch what happens to the dots. They all start moving away from each other, right? No single dot is the center of the expansion. The expansion is happening everywhere on the surface of the balloon. This is precisely what astronomers observe when they look out at distant galaxies. Everything is moving away from everything else, which tells us that the universe is still growing today. This expansion wasn't just a one-time event, it's an ongoing process. The Big Bang wasn't a bang in a specific place, but the beginning of space and time itself. In those first few moments, the universe was a super hot soup of fundamental particles. As it expanded and cooled over millions of years, those particles came together to form the first atoms, mostly hydrogen and helium. Gravity then went to work, pulling these atoms into massive clouds that would eventually ignite to become the very first stars and galaxies, lighting up the cosmos for the first time. All right, now for the really mysterious part. When astronomers started adding up all the stuff we can see, stars, planets, gas, and dust, they found something startling. All that visible matter only makes up about 5% of the entire universe. That's right, just 5%. So, what about the other 95%? Well, scientists believe it's made of two invisible ingredients: dark matter and dark energy. These are some of the biggest puzzles in science today, and they're fundamental to understanding how our universe works. It's like trying to understand a forest when you can only see one out of every 20 trees. Let's start with dark matter, which makes up about 27% of the universe. We call it dark because it doesn't emit, reflect, or absorb any light, so we can't see it directly with telescopes. So how do we know it's there? We see its effects. Think of it like the wind on a blustery day. You can't see the air itself, but you can see the leaves skittering across the ground and the trees swaying back and forth. In the same way, astronomers see the gravitational pull of dark matter on things we see, like stars and galaxies. It's the invisible scaffolding that holds galaxies together. For example, scientists observed that galaxies are spinning way too fast. Based on the amount of visible matter they contain, the stars on the outer edges should be flung off into space, like kids flying off a merry-go-round that's spinning too quickly. But they aren't. They stay in orbit. The only way to explain this is if there's a huge amount of extra unseen mass providing the extra gravity needed to hold everything together. That unseen mass is what we call dark matter. It forms a massive invisible halo around galaxies, including our own Milky Way. Then there's the biggest player of all, dark energy. This mysterious force makes up a whopping 68% of the universe. While gravity works to pull everything together, dark energy does the exact opposite. It pushes everything apart. Scientists discovered this in the late 1990s when they were studying distant exploding stars called supernovae. They expected to find that the expansion of the universe was slowing down due to gravity. Instead, they found that the expansion is actually speeding up. Dark energy is the name we give to whatever is causing this cosmic acceleration. It's a kind of anti-gravity force woven into the fabric of space itself. So here we are, floating on a small, rocky planet in a vast and dynamic cosmos. It's a place filled with wonders that can fire up anyone's imagination. At the heart of most big galaxies, including our own Milky Way, there's something truly extreme, a supermassive black hole. These aren't just big, they are cosmic monsters with the mass of millions or even billions of suns, all crushed into a tiny space. Their gravitational pull is so powerful that nothing, not even light, can escape once it crosses a boundary called the event horizon. They are the universe's ultimate trapdoors. But don't you worry, our solar system is a safe distance from Sagittarius A*, the supermassive black hole at the center of our galaxy. We get to study these incredible objects from afar, learning how they shape the galaxies around them. Black holes aren't just cosmic vacuum cleaners. Their immense gravity influences the orbits of nearby stars and can even trigger bursts of star formation. They are an essential part of the galactic ecosystem, playing a role in the life and death of stars and the evolution of the galaxies they inhabit. It's a powerful reminder of the extreme forces at play in our universe. Every time we point our telescopes toward the sky, we discover something new. We've found thousands of exoplanets orbiting other stars, some of which might even be rocky worlds like Earth. Could there be life out there? We don't know yet, but the search is one of the most exciting frontiers in science. Every discovery, from a new galaxy to a strange new type of star, adds another piece to the puzzle. We are living in a golden age of astronomy, where technology allows us to see farther and more clearly than ever before. The universe is a book, and we've only just begun to read its first few pages. So I want you to remember this. Your curiosity is the most powerful tool you have. The universe is big, it's mysterious, and it's full of unanswered questions, and that is fantastic. It means there is so much left to discover, so much left for your generation to explore. Keep looking up, keep asking questions. Whether you become an astronomer, an engineer, a teacher, or anything else, stay curious about your place in the cosmos. Because understanding the universe is really about understanding ourselves. The adventure is just getting started. Go get 'em!